Dear students, today we will study regarding the polynomial class and non-deterministic polynomial class algorithm. Let's start. So, we have already discussed regarding the complexity. Complexity are of different type like big O, big theta and big omega. Now, let's have a small recapitulations of this. Like big O, when we say it's big O or when you count the complexity in order of big O, that is if and only if there exists a positive constant C and then 0 such that it covers the upper limit. By O notation to give an upper bound of a function. So here is the graphical representations of this big O notations. Okay. Now omega notations. Big O provides an asymptotic upper bound on functions. Omega provides an asymptotic lower bound on a functions. Now the omega notation, if there exists a positive constant C and then 0 such that is the constant C Gn should be less than Fn and C Gn should be more than 0. Where n and n0 both are the integer values. Now here you can see how the omega notations are represented in the form of this plot. So already we have discussed regarding this also. Now there is a theta notations. So theta notations, in case of theta notation, we need to follow both the upper bound and lower bound. So theta notation is basically implement the tight bound of an algorithm. So here in the graph, we can see the tight bound of a function is tightly bound with two different functions, that is C1gn and C2gn. Now here we can see that there is the different types of big O or the big O complexity, how they are represented in the form of like constant, it is order of 1, order of log n, order of n, and we have done so many of algorithms like say binary search, order of log n, then we have quick sort, order of n log n, merge sort, order of n log n, and then you have done like linear search, order of n. So whenever we have done all these algorithms follow a particular polynomial notations. So that is what is known as the class P algorithms. So the class P consists of those problems that are solvable in polynomial time. More specifically, we can say that the problem that can be solved with the order of n to the power k. Okay. And in the class, I have already discussed that what is the n? N is nothing but the size of the input values. Like whenever we work with the n number of data items, the size of the array that we are doing the problems, then n is the size of the array that is used for our program. Now say here we are considering the complexity of that is primality testing. What is primality testing? That is nothing but a prime number. So all of you have already done this kind of program, that is to find out whether a number is a prime number or not. To find out whether a number is a prime number or not, we need to find out that whether the number is divisible by 2 or any other numbers except the number itself and by 1. So for that, we have to continue the loop up to the square root of that particular number n. So with this loops until the square root of the number n. So here we can say the order of the functions or the complexity of the function should be order of the square root of n. But what is the input size? How many bits does it take to represent the number of n? Log n is equals to k. Then the root n, it should be represented as 2 to the power k, that is to the power 0.5. So that we can say to find out whether a number is a prime number or not. This function has, that is named primality testing is an exponential. So the time required for this function to be solved, it is exponential, right? Now, this is a very new term to all of you. So until now, whatever we have discussed is already known to you. That is, we can calculate the complexity of a program. Then in the polynomial time, okay, in the polynomial time, it can be solvable. Then that kind of problems that exist in the a P class, that is polynomial class. Now let's come to the NP class. What is NP class? NP is not the same as the non-polynomial, but NP stands for the non-deterministic polynomial time. Okay, so what is meant by the non-deterministic polynomial time? NP means it's verifiable in polynomial time. That means whenever we consider the NP class problems, then that type of problem is not solvable in the polynomial time. But after when you get the solutions, then that can be verified whether it is true or false in the polynomial time. So verifiable means that if we are somehow given a certificate of a solution, we can verify the legitimacy in a polynomial time. That means the solutions that we are getting after completions of that algorithm, whether that particular solution is valid or not, that can be identified or that can be detected in the polynomial time. Okay, so that is what is NP problem or NP class problems. So NP class problem that include the graph theory, where we have like shortest path problem, then we have like Eulerian distance problem, then we have any kind of graph, say graph coloring problems. If we have any kind of graph theory problem, that can be, or a traveling salesman problem, in case these are all like of NP problems. Okay, let me discuss regarding what is the relations between the NP and P. So for that, I have to draw the set diagram. Let me consider a large set. So this large set is considered to be NP class. Right? That means we are considering that all the problems that we have in our that is all are the NP problem. That is, they are not solvable in the polynomial time, but that the solutions can be verified in the polynomial time. Some of the problems that may be solvable in the polynomial time, among these NP problem, they form the inner set that is termed as the P class, that is polynomial class. So we can say that P class is the subset of the NP class. Okay, so most of the problems are NP class. Now those problems that can be solved in the polynomial time, that belongs to this P class. So P class basically it's a subset of this NP class. Fine. So I think now understand what is the relation between the NP class and P class. Okay. So, like, say, if we want to find out the shortest path algorithm, let me define with an example. Say there are some of the nodes. Why it is, I'm calling it as a NP. Say some nodes are there and they have the path. It's an undirected graph I'm drawing. Okay. Now let me have some values or some cost. So here some color to the notes. Say red node is the source node and pink node is the and say the blue node is the destination node. Right? Red node is the source node and blue node is the destination node. Now, if you are asked to find out the shortest path from the red node to blue node, then how could you find it out? Now, from the red node, there are three paths. That's one goes to the yellow node, one goes to the pink node, one goes to the green node. Where red to yellow having cost 1, red to pink having cost 1, red to green having cost 2. So as I want to find out the shortest path, so I should choose among the paths having cost 1. So here there are two different paths. So there is a problem that we can have during the making of my decisions. So whenever there is a yes no answer that whether I should follow the path yes or no, then that kind of problem is basically NP problem. Okay. Now there may be multiple solutions from the node red to node blue. So we can follow the path red, yellow, blue. We can follow the path red, pink, blue. We can follow the path red, yellow, then green, then pink, then blue. So there are different paths from red to blue. Now we have to find out the shortest path. Whenever we find out the shortest path from red, we have chosen say yellow. Okay. Then again from yellow, there are again two different ages. One is 2, another is also 2. Red to blue, red to green. Fine. Now I can follow red to green or I can follow red to blue directly. I don't know when I am at node yellow, I don't know what is my next node. So I can follow this path or I can follow this path. So there is also a decisions making problem we may have. So here we can say this is a NP class problem. But whenever we find out a solution, say I find out the solution, the path from red to blue is red, yellow, blue. Then it is verified that yes, we can directly verify it in a polynomial type that yes, it is a correct path from red to blue. Okay, that means it is a non-deterministic polynomial problem. Okay, so that I want to discuss over here. So that's all for today's class. So students, we just go through this and we will discuss regarding this in the next class. Thank you.